Well, I appreciate the opportunity to come here. Been working with Ed and Matt over the last couple of months, and just want to share what we have learned about OCR technology over the past several years. Kind of a changing field, and I just want to throw out real quick, you mentioned the accessibility, Kevin mentioned PDF UA, or the accessibility standard. PDF UA is an emerging standard. It's ISO 14289. And I found a real interesting document on the web about that. It's called, if you just Google PDF/UA in a nutshell. So it's one of those evolving standards. PDF/UA in a nutshell. Very interesting. Case that's working on developing, it's not really quite there yet. Came out last year. And something that we're keeping our eyes on because we're responsible for meeting all these various standards. To give you a little overview, we're going to run through some definitions, current state, where OCR is at, challenges, some trends, a brief recap. Just a little bit about myself. I know the education industry pretty well. I was a professor for 3 years prior to coming in this. I took a little break from my professional career and did the teaching thing for a while, so understand it. I'm pretty well about business for 3 years at the college level. So worked with a lot of professors, so I see it from that kind of perspective. I come from a family of teachers, so no surprise. The definition of OCR, I'm not going to bore you with fine details, technical details, but I think it is interesting to recognize the definition of electronic conversion of images, typed, handwritten, printed text, and machine code text. Now that includes, it's kind of broadly includes things like handwriting recognition, which is ICR, and also things like optical mark recognition. When you complete a form, there's a check mark on there you check, it's called OMR. And also something you can look at if there's a signature box on a form. We'll just look and see, is there anything written in that signature? And that basically is signature, it's called signature presence. We also can capture an image of that signature as well. Barcode recognition. So very much standard. It all kind of falls into OCR. When you scan a form in, we recognize the barcode, we use that to assign metadata to the document. Okay, now this is the current state. So kind of where are we in 2016, and then we're going to talk about trends. There's a small group of mature OCR engine suppliers out there. Been around for a long time. They have tremendously huge investments in their technology, and that's important when we get up to the next several points. Release level 10 and above. If you know anything about the software world, usually have about one major release. If you look at like Adobe Reader, version 10, 11, usually about one per year, maybe a little bit less than that. So if you have like between one per every 2 years, these guys have been working on this for like 20 years. So they have a huge investment. I would say that several of these products are considered a commodity for terms like Kofax, Abby, Nuance, if you ever use Paperport, OmniPage. And that's especially the case within government. Many times government and even universities will have schedules, and they will look at these things as commodities, and they'll just buy them as commodities usually throughout the company. Commercial products include advanced feature sets as standard. So things like despeckle, despew. We're going to mention in a minute the difference between an engine and an application. The engines a lot of times require a lot of programming to create an application. So that's a big difference between the two. So the applications generally include things like despeckle, despew. It's important because if your document's twisted, it's not going to do a very good job in OCR in reading off the characters. So in general, when I say OCR, we're usually reading a scanned document. Could be a book on a book scanner, and then converted into a editable form, say Microsoft Word or Excel. Many times what we're doing though is just taking that text, making a searchable PDF, and also grabbing data off of that document to use for indexing. Maybe it's like the title of the book, the date, the ISBN number, something like that. And if there's a barcode in there, we can look that barcode up and use that automatically as well. Many times what we do is when we scan the document, we put a barcode on intelligently for a reason. We have an application over here that does a lookup, puts a barcode on, and then we use that for metadata. Okay, important point here. What we see in the university world is widespread use of open source technologies, all the different portals, the Joomlas, Googles, Omicas, that type of stuff. And there are several open source alternatives for OCR. They're just not really very good yet. That could change in future years. Things like TestRat, Google OCR, Cuneiform, they're out there. You can use them. They work okay for small documents or really good quality documents for like narrow specific applications. And note on the slide, the main reason is that the commercial vendors invest a whole bunch of money. So they're not going to just broadly openly share this technology, at least yet. Also, globalization drove the need for many languages. So they had an OCR technology applied to, say, English, maybe Arabic, a couple other like popular languages. And then they also find out they need Japanese, Chinese, simplified, all the different versions of Chinese, Mandarin, and they had huge investments for that. So they're trying to recoup their costs. And I mentioned before, open source really works well for kind of narrow, specific projects on a clearly defined document. You don't have a lot of options also in open source for handwriting recognition or optical mark recognition. Some of the main players in OCR, you've probably heard of some of these names if you've been involved in OCR work at all. Abby and Nuance, probably two of the best known. So you might do well just to Google Abby, Nuance, read about them and the products that they offer. Some of these smaller ones are out there, very good products. And functionality-wise, they're all really quite similar. They're all competing with each other. Important to remember the large difference between OCR engines versus applications. So an engine is just something that's just crunching behind the scenes, an SDK, software development kit, and we build applications from them. So the application then might be a way of, say, a scanning interface to scan documents, and it's using this engine behind the scenes. And then maybe it puts it in SharePoint. Or maybe it goes to SharePoint, checks the document. It asks, are you OCR version? Or if you aren't, go ahead and OCR, you check it back in. Stuff like that. That's an application. An engine won't do that. But the engine's doing the work behind the scenes. Yeah, I say they're mature technologies, the cash cows. The applications are the rising stars of Boston Consulting Group, the MBA people will know what I'm talking about here. So that's the area where these companies see lots of applications happening from their existing engines. So they invested all this money in these engines, and now they're moving into this application development. This OCR technology unlocks applications like crazy, as I mentioned, the rising star. Document classification. When we look at a document, so we read a document in, I try to figure out, what is that document? Is that a letter? Is that an invoice? This looks like a purchase order. Well, how's it different? What's a purchase order? How's that different from an invoice? Basically, we develop a series of rules to tell them apart. We use this in digital mailroom. So when a letter comes in to a mailroom, normally we just route it to the employee. You know, box 11 goes over here. So some companies have gone to actually scanning in documents in the mailroom and eliminating the mailing process. So we can perform rules and tests on those documents as they're in the mailroom. Maybe it's like a lawsuit happening, and we can then get a maybe 1 or 2 day quicker notification, something like that. I say an illustration. Yeah, I know of an illustration where a company had multiple letters coming in, threatening like letters, and it was an insurance company. And one day the sheriff's department arrived in the lobby. It was kind of embarrassing for the company. And basically said, you know, we're authorized to take away, you know, $100,000 worth of equipment because you've ignored all the letters. Because there was a claim against them and they never paid the claim. So kind of embarrassing. So possibly technology like this could prevent that, maybe a little bit better than what happened. Here we have a letter displayed here, and what I'm showing is, I'm going to read that letter in. I'm going to take that addressee name at the top, and then I'm going to use that to either put into a database to file that document in an archival system, or I'm just going to put it in the file name, and the file name is basically metadata, right? It's like foldering. Drop the author name, add this to the file name. Invoice processing, big area. easily becoming the most popular product for OCR vendors. So they take the underlying engine technology, we read an invoice, we read off the line items, we do a general ledger lookup to determine the GL code for each of the line items, we find the vendor, business unit, and then we put it into an accounting system. Meaning-based is kind of an emerging science. In my example, fire a cannon versus fire a clay pot. So if we're involved in a legal discovery or in the digital archival world, I want to do a search. If I can eliminate any of these fire the pot searches versus fire a cannon search, I can maybe cut my search results maybe in half. So when I assign semantics or meaning to these words, it's much different than just the flat word. Some challenges. Performance has always been a challenge in OCR, and it probably always will be. I mean, it was probably what drove technology to go to hardware OCR, some proprietary, like the post office used. So we trade CPU cores for performance. As we add CPU processing cores, performance goes up. Pretty much linearly for the commercial products, not so much for the open source solutions. So for OCR, we're looking at average documents like a half a second to process per page. That's kind of a rule of thumb. A 10-page document, you're looking at like 5 seconds. So you have some big documents in the digital archival world. So those things can sit there and crunch for minutes, hours. When we look at increasing OCR quality, then there's a sacrifice in speed. So we scan documents at 200 or 300 DPI. That's one thing, is we scan at 600 DPI, and we expect higher quality OCR results and slow things down. 50% different. Small fonts can be challenging. You guys scan a lot of small fonts. I've seen some of the documents. We've been sent problem documents, run them through Nuance, Abby, just to see what they do. And yeah, small fonts can be trouble. It's going to get better, I think, as more of this application development puts more dollars into the OCR engine side. Probably that will drive better results in small fonts. Pricing can be daunting of commercial products. We're used to the open source. I want to put a Drupal website up, click, free, done. There's no price to worry about. So they look at a lot of different price models. A lot of them are per page, maybe per page per year. Maybe we look at CPU. You can run all the documents you can per CPU. That might be a couple $1,000 for something per CPU. The OCR Engine APIs are complex. There's a learning curve. So it drives business to people like us that have the engine expertise. I'm not saying you can't walk into an API engine and just figure it out. You can't. The skilled developer can't. But the calls are very, very low level. So it's definitely a learning curve. So like I said here, limited knowledge base drives business to people like us. PDF UA, I mentioned this ISO 14289, and if you Google PDF/UA in a nutshell. Very good document. It's kind of hard to understand what's going to emerge from that. So we're keeping track of these accessibility requirements, and there are testing programs out there. You can test the PDF and to see if it meets them. So I think we're just going to kind of see where this shakes out. Template development, we look at extracting information from a document. We use templates, we use rules, we use search strings. You'll see it in the demo, and that can be pretty involved. There are wizards that do it. Wizards still build templates behind the scenes. We're seeing a trend now, so we're moving on to trends. If we get ready to finish up here in the next 5 minutes or so. PDF/PDF archive format's pretty much becoming a trend. It's pretty much what we're seeing people using. 20 years from now, we don't have to open up the PDF. Even 50 years from now. We don't want to have to go back to a PDF we created in 2010, put it into OCR Engine, and then fix it so that we can read it 20 years down the road. Automatic classification is definitely a trend. So we're seeing larger volumes of documents, especially old books and stuff scanned in. And what we need to do is index this information so we can find it. So as the volume of information increases, if we can't find it, it'd be basically useless. I can't tell you how many times I go to my computer or to my SharePoint library and I'm doing searches for stuff, and I'm like, I know I have it somewhere, but like for the life of me, I can't find it. Sent items in Outlook, it's like horrible. So that's very important. So classification of documents is just a huge need. So that's an application the OCR companies are really advancing upon. Automatic language detection is pretty much standard. They assume on the order of about 175 languages out there. So pretty much when you buy an OCR product, it's going to have that standard. They'll always have limits. OCR is always going to have limits. You can't fix, if you can't read it yourself, it's not going to be able to do an OCR. Simple as that. Especially handwriting is really, it's just not there yet. Handwriting in narrow, specific areas on the document is pretty good. But handwriting, like free-form handwriting, comments on a form, no, it's never going to do it. Fuzzy techniques, I'm just going to run by this database lookup. We can use that to improve results. Lexical, as I mentioned, meaning-based analysis is a huge trend. Huge development of OCR applications. I had mentioned natural language text processing using some of the semantics, meaning using statistics. We're looking at light and dark areas on a document to figure out this looks like a letter, this looks like a contract, it's got a lot of logos up here, this must be an advertisement document, a marketing document. Legal contract may have a legal stamp down on the bottom from some court system that's pretty much always there. So guess what? We can always look for that because we know it's always there and identify that this is a Los Angeles court document. Template training. A lot of, this been, in the last 5 years, a lot of systems come along that help us to learn documents. So like these wizards, automated wizards. Automatic classification, kind of the same thing. I beat this a million times about application development versus SDKs, where you won't do that too much. A trend to go to the cloud, to put applications in the cloud, or on virtual servers within the universities and colleges. Amazon is definitely in the forefront for this. Migration from premise-based to the cloud, I mentioned. Great thing, because when I'm in a virtual environment and I have 2 cores on my OCR and I want to go to 8, push the button, change it to 2 to 8. No charge when they're not running. Nice thing about Amazon. Yeah, so what we're doing when we move stuff to the cloud, it's almost basically a complete talk in itself. Advantages, disadvantages, security. It's just things to think about. Maybe that we could have a whole rack of servers turned off, and we just put it in the cloud. Turn it off, don't pay for it. Except you pay for a static IP if you want to have that IP exposed to the web. Pay for a static IP. I'm going to just give a quick recap, and then we're going to move on with the rest of the day. We're going to have a couple demos today. We're going to have a FlexiCapture demo, which is an automatic indexing system, and then after that, we're going to have an Handwriting Recognition server demo, which is just a server-based OCR and does some smart extraction as well. Key points, this is a recap as I finish up. So we have a small set of OCR vendors with a wide breadth of knowledge, and they all sell their SDKs too. Well, most of what they're doing is selling applications. Right now, limited open source options. That could change, who knows? Trend is towards the advanced application development using these existing engines. And many times that is offered by the company that makes the OCR engine, and in many cases, outside companies take those engines and make their own products. Trend towards automatic advanced digital classification, so automatic classification, as I mentioned. Cloud-based processing, definitely a trend. Okay, like I mentioned, so we're going to be showing later this morning FlexiCapture. This is the automatic extraction technology. There's a learning curve with it, so I'll try to minimize that. We're just going to kind of do a quick run-through. And then every recognition server, server-based OCR. What I've done is I've developed some use cases. So I have 2 use cases for FlexiCapture, 4 for recognition server. And then on there, we just kind of list what we're doing. It's always a good thing in project planning, we're doing these OCR. Like, what do we expect? What do we want to achieve? Then when we beat that, we look back at our document standard we get, and we just look and see, hey, you know what, we beat these goals. So it's always good to kind of do some planning, because we have high expectations for project. So thank you very much, and we look forward to doing that demo later this month.